Right now, you're thinking, who in the wide world of sports is this old baby boomer cuss that looks like he needs a haircut, and what does he want from you? In 45 seconds, I'm going to list some very special people who may find this video a life changer going forward. Are you in high school? Can't wait to graduate and get it over with, and hopefully not see the inside of a classroom for a long time? Does the thought of 4 years in college and the huge amount of money that takes preclude you from going? Did you leave school without graduating? Or were you like me? I was expelled in March of my senior year. Are you stuck in a low skills, minimum wage job that's boring you to death and has no visible future? Are you a veteran, trained in a military specialty, which has no direct civilian crossover for your skills? Do you know anyone who meets one of these descriptions? If so, would you please pass this video along to them? I have a fascinating deal for you. How would you like to learn a time-honored skill set that provides a good middle-class living at the cost of less than 1 year in a state university? If you think you might like creating things, working with computer visuals, handling sophisticated tools, activating precise machines, and holding the results of your work in your own hands, follow me here. My name is Jeff Howard, and this is an introduction to modern computer numerically controlled machining, where we take an idea and a nondescript piece of material, and with our hands and our brain and a powerful computer-controlled machine, we can accurately machine that into valuable products for the marketplace. We'll take a look at manual machining first so that you can easily see the principles involved in full view. This is going to be about a 2-minute loop to show you manual machining and the basic procedures involved in creating a part. Manual machining starts with a drawing by an engineer somewhere. He hands it to a machinist. The machinist picks up a piece of stock, collects the tools, goes to the appropriate machine, and creates the part by removing material. Now we're going to be using 2 different machines in order to make this particular part. As you can see, we have a drawing. It shows 3 different views of the part that are dimensioned, and a 4th just for the idea of what the part will look like when it is completed. So what we're going to do here is we're going to run through how we do this and do it as quick as we possibly can. Keep in mind that good machining programs are taught all over the United States. We're just dealing with the one here in Kirkland, Washington at Lake Washington Institute of Technology. I just showed you a quick view of manual machining, which any good program will teach as the basis for learning computer numerical control, or CNC machining, which we'll pick up next. We will learn to create the product on a screen in 3 dimensions. We will learn to program the various tools that the machine is supposed to use to create the part, just like we did by hand. only totally controlled by a computer. And then we will show how that machine actually can make this part in about 1/10 of the time that it took to make it manually. Okay, to create this part, we're using computer-aided design, CAD software. We start out with a sketch of the outline of the part. And then what we do is we create what's called a revolve around that sketch and create the solid part. Then, to make the flat part, what we do is we create another sketch. And this is going to be a cutter. If we watch exactly how this works, when we unsuppress this, we have cut the flat part. Now, what we're going to do is we're going to create a chamfer on these edges to soften them up a little bit. You see these sharp edges? Well, we put a chamfer on there and it softens the edges up. The machine will do that. Then we create the hole. We use another sketch right here, which shows exactly where we want the hole, how big we want the hole, and so forth. And then we just cut the hole and we have the part. It's complete. So that's how we create the part in CAD software. Next, we will load it into computer-aided machining software. We have the part loaded into our computer-aided machining software called Mastercam, although there's several different programs that do very similar things. As you can see, we have our part here. We have the stock that it's part of. It's clamped in the chuck in the lathe. And what we're going to do here is we are going to run these various tool paths where the machine selects the tool, uses it to create the proper surface, puts the tool away, starts with the next tool. So how we do this is in virtual reality here. We can see whether we're going to destroy the part or crash into the machine or do something damage or something. We can basically finesse the machining of this part without ever touching a machine. And we'll go ahead and run this thing real quick, and we see the tools virtually going over the part. Then we're going to see it finish, mill the flat, and then we're going to punch the hole, and then we're going to cut it off. There, it's done. Now, we can do another way of looking at this, and we can watch this one. Very similar. Does the facing, does the profiling, creates the flat, punches the hole, and cuts it off, and we're done. So now we can create the code that goes into the machine, which tells the machine exactly what it's supposed to do. Okay, here is where we get the magic. My program at home is a student edition. It will not post code. So this is the school computer, and what I've done is all the little tool paths that tell which tool to use, when, where, and so forth are all checked. And I go up to this magic little button here that says G1. I press it once, I say OK, and I give it a name. And say save. Now watch this. In a few seconds, this thing is going to generate all the code that I will feed to the machine to make this part. There it is. Watch this code. It's pretty long. All this G code here. All this code right here is what's telling the machine exactly what to do. All the way from the beginning, each tool is pulled, each tool is used, each tool is put away, and the next tool is pulled. And all these little tool paths have been turned into code. And I will save that into a thumb drive. And I will take that thumb drive and I will put it in the machine and feed that code into the machine, and then the machine will make the part. Here's our machine shop at Lake Washington Institute of Technology. This is a CNC lathe. This is another CNC lathe. This is a CNC milling machine. As you can see, there are many tools in that magazine which can be switched out by the machine to make different parts. Here's another CNC lathe. You'll notice the turret there has many different tools on it for many different purposes. The turret rotates, as you will see, and puts the appropriate tool against the part, which is down here, and turns it to the proper shape. This is the control unit where we feed the code into the machine. Now the machine we use, these are manual machines. We have several of them. These are manual milling machines. As you saw making the wiffle pin, only these are a lot fancier. This is a machine we make the wiffle pin on. This is a Doosan Lynx 1220 LSY. It is the most capable lathe we have in the shop. And here again you can see the turret with many tools. The turret will rotate, bring an appropriate tool up to work on the part, and then pass it back and forth and create the shape of the part. I know what you're thinking. The old guy cheated on us and used plastic in the CNC machine instead of metal. Well, that was done because of the fact when we machine metal, we have to squirt liquid coolant on it, onto the tool, onto the part, all the time it's being machined. It would spray everywhere. We had to put the camera inside the machine to get a good shot. It would have ruined an expensive camera. But we did set the cuts just the same as we would have done for metal, so it didn't go any faster. And no, I did not speed up the camera for that. 3.5 minutes to make that pin, which basically improved my personal production by a factor of 10. Now, we're going to take a couple of quick looks at a wonderful precision machine shop nearby that many of our graduates go to work at soon after they leave our school. It's called Gemco, and it is a magnificent place. Guys are making good money there. It's something to think about. Also keep in mind that machining is taught all over the United States, in junior colleges, in technical colleges, in trade schools, and so forth. So, just because you don't live near Kirkland, Washington, where our school is located, you can find some place to learn this trade. This is the inside of Gemco. They're a machine shop in Kirkland, Washington, where many of the graduates of Lake Washington Tech go. Several of them are here. These are milling machines, I call them, or production centers. Here's an example of a part that was made here today. These parts are made for many different manufacturers, and they are then inspected in a separate area and made sure that they meet specifications. This is a modern machine shop. It is well lit. It is well maintained. The students who came here from our school have advanced, gotten pay raises. We'll bring you down to another part of the thing right now. These are a couple of manual machines. They see very little use these days because everything is done with a computer, numerically controlled CNC machine. Here are some smaller CNC machines with some operators. Isn't it amazing? This is the inspection department. Every part that they build is inspected to very, very close tolerances. These are CNC inspection machines. This machine is inspecting this part to make absolutely sure that it meets the specifications of the customer. These granite tables are completely level, and parts can be laid on them and inspected and measured with various different machines, like these machines here that are hand operated. Here's a box of parts that have been inspected and they'll be going out to the customer in short order. Keep in mind that these parts are made to very, very exacting specifications, and it has to be confirmed in this room before they are shipped. Well, that wraps it up. Really appreciate you staying with us on this. For you, this may be the building blocks of a completely new career if you're interested. And we're going to provide an email address for you to inquire about perhaps having a tour of the shop or a description of the program more accurately than I can give you. It's a good chance for a future for some people, so think it over. And thank you so much for watching.